Hey guys, how's everybody doing? So we're here in the classroom looking at an ignition system. Now this is an ignition system trainer, and there's two complete different styles of ignition systems that we have on this trainer. So no, you normally will not have all of these wires, just kind of looking like this jumble right here. But basically this is two complete ignition systems that are on one unit. So over on this side, we've got an old style ignition system. Now, this is the style that uses a separate ignition coil right here. And then you see we've got wires going to what's called our distributor. And our distributor, this guy is what is driven by the engine. As the engine turns over, there's a drive gear somewhere, usually off of the oil pump, driven by the camshaft, driven by a gear, a rod, something drives our ignition coil right here. Okay? And inside of this coil we have what's called points. And let me pull the cap off here if I can and show you guys what's going on inside of this ignition system. Of course, I can't pull the cap off very easily. Got one screw here, and it's kind of hard to get at it with one finger. There we go. But this is our distributor cap. Now, coming out of the cap are our ignition wires, or our spark plug wires, or high tension wires, whatever you want to call them. And they go by several different names, and depends on kind of where the car is made or what country you even live in as far as what these guys are going to be called. But they're just spark plug wires here in the good old America. This is our distributor cap right here. This is usually a very thick plastic. It's thermal resistant plastic, so it's made to withstand very high temperatures because this is all under your engine bay. Inside of this distributor cap, you see we've got some metal contact points right here. We've got contact points on all four corners of this cap, and then we've also got one right in the center. Now, each of these four outer contact points is connected to a spark plug wire. The center of our distributor cap, that middle contact, is connected to down here on our distributor. This is our rotor button. Okay, and you see we've got metal coming off of it that connects to the center electrode center wire of our distributor cap. And then off to the side right here, it runs out to the side, and we've got a little metal right here. That is what touches our 4 points of contact in case of this distributor. So what's going on inside of here as our car is running? And let me just turn this little guy on real quick. Just for a second, we'll see it spin here. This rotor button is going to start turning. So you can see as it turns, these metal contact here on the edge will spin around as the engine spins. And as it spins, it contacts these four metal points inside of our distributor cap. Okay? What that does is it distributes our spark to each spark plug wire, hence the name distributor. So like I said, this was an old style distributor. This is what was on cars. They were still popular into the 70s even, but pretty much by the 80s this style had died away. But like I said, classic cars, you're still going to see this style. And this is called a points type distributor. And basically what I mean is right here we have something called a breaker point. Okay, now this little guy, what his job is to open and close. And I can just kind of grab it with my finger here and pull it open. Or better yet, I'll spin this rotor button around. And you see as I spin the rotor, my points are going to open and close. So basically what's happening is there's a little cam lobe on our shaft of our distributor that this this rotor button is attached to, that as these little cam lobes come around, you see these points opening and closing, and there's a very small gap. They don't have to open and close very much, but they do have to open and close a tiny, tiny bit, and they're called breaker points. The reason they're called breaker points is they break the electronic connection on the primary side of our ignition coil, okay? And I'll get more into that, what that means in a minute as far as our primary and secondary sides. But these breaker points will break the connection and allow our coil to basically generate spark and send that spark out to each individual spark plug, okay? That spark is sent from our coil through this spark plug wire, and this spark plug wire from our coil happens to attach to the center of our distributor cap. From the center of our distributor cap, it comes in, it goes out to the edge, and then it waits. It waits for this to come around and touch one of these 4 electrodes, 4 points on our distributor cap. It then sends out that spark to whatever spark plug is connected to that wire, and bam, we have a spark in our engine. This little guy right here is called a condenser. He just stores extra energy if needed. Okay, it kind of acts a little bit like a battery. It's not necessarily to boost electricity. It's just more to store it, to even it out, because we have voltage going across our breaker points. If we didn't have this condenser, they would burn up. They would get black and corroded because of the electricity moving through them, and they wouldn't last very long. So we have this condenser to kind of smooth everything out and help our breaker points last longer. Now, the reason we've done away with our breaker points is because, like I said, these can burn up. They do over time naturally. They're a wear item. Every time you did a tune-up on a vehicle with these breaker points, you would have to replace the points. You also have to get this gap perfect, or too much gap, too little gap. You would not have a strong spark or any spark coming out of your distributor. So that was kind of the hassle with these breaker points. So we have done away with this style of distributor. So let me put this cap back on here. Now that we've seen everything inside of it, I'll just kind of screw this little screw in. You see I'm working with 2 fingers here, trying to get that screw to screw in so this cap doesn't fly off. So how does this work? Okay, well, let's turn it on. So we'll have some engine RPMs, and this will be loud. I apologize for the audio quality if it gets to be bad. So our distributor is now spinning because our engine is running, and that's the electrical motor. We have an electrical motor spinning this, obviously, and as this spins, again, our coil is generating voltage and sending that voltage to the center of our distributor, which then is sending it out to each individual spark plug. Our spark plugs are right there. What does this spark look like? Well, if I look down here, you can see the little electrical flashes. That's our spark happening. And it may or may not be kind of hard to see here, but we actually have spark on all 4 cylinders. Okay? So there was our old system right here of using breaker points and a separate coil. Over on this side, we have the evolution of that, and this is GM's evolution of that. This is an HEI, or high energy output, or high energy ignition distributor, okay? You notice there's no separate coil wired in somewhere like over here. Instead, GM puts the coil built into our distributor cap. Then we still have spark plug wires coming out too. In this case, we have 8 spark plugs. This is off of a V8. This little guy over here was a 4-cylinder. It would work the same whether it was 4 cylinders, 6, 8, 10, 12, whatever. But in this case, we do have a V8 style setup right here. We still have a distributor cap. We still have a coil. But inside, if we pull the top away, so as I pull the cap off of our distributor right here, and again, distributor is still driven by the engine. So I pull this cap off, you notice the inside is going to look a little bit different. Okay? Now, I can't get it back very far because you see I've got wires still connected. But inside of our distributor, we still have a rotor button right here. Okay? Same thing. Still engine driven. I still have a metal contact on the end. I still have a metal contact in the center. We still have metal contacts for each spark plug wire. The one thing you'll notice, there are no breaker points inside of this. If I could remove this rotor button easily, you would see that instead of breaker points, I have what's called a Hall effect sensor under there. Basically, a Hall effect sensor is something magnetic, a magnetic trigger, a magnetic pickup that basically turns on and off my ignition coil electronically. So no points, which means less to wear out. This guy is more efficient. It's going to work better than this guy. Reliability, more reliable, more miles between tune-ups was the whole plan of this HEI ignition. And GM, Ford, Chrysler, everybody kind of went to this over this style pretty quickly after it was developed. So let's see how this guy works, okay? Again, this is a V8 engine, so we are going to see a few more sparks here, but it's going to work pretty much the same. So we turn it on, and we hear the sparking going on here. So let's see these sparks, and if you can see down here, there's our spark plugs firing. Each one, and I've got 2 banks of spark plugs. They're all firing. Okay? Now the nice thing about this is I can adjust the gap with this. I can make it shorter, I can make it bigger, and you hear as I close the gap down, that sparking sound gets quieter. If I open it up, it gets louder. Why? It has to work harder to jump that big gap. So we hear the spark. It's just like lightning and thunder. You know, we have lightning and then right after it is thunder. That's kind of what we're hearing. We're seeing the lightning and the thunder of an ignition system. Okay? So, again, this is just 2 basic ignition systems. Over here we have the very old style. Here is an older style. Now, you might still see these. They used these into the 80s and the 90s. So you might see these on, I wouldn't say really old, but older vehicles. And there's how that style works. All right, guys, and right here we have a fairly modern ignition system. Now, this is what's called a waste spark type ignition system. And we still see these on some vehicles today, but it's not as common as the coil on plug or coil near plug ignition systems. So this is what happened after the GM HEI ignition system ran its course. We came up with something called a direct ignition system. Okay, and basically what that means is I have no distributor now. Instead, I rely on sensors located somewhere on the engine to supply an ECU, a computer, with an electronic signal of where in the stroke and which stroke I'm on. We send that info to the car's computer. The computer then can say, I need to fire a spark plug, or I don't need to fire a spark plug, or I need to fire cylinder 3. Now I need to fire cylinder 4. Now I need to fire whichever cylinder. Okay, so this is what's called a direct ignition system, and like I mentioned, it is called waste spark. Down here I have my ignition coil. Okay, you see I have plug wires, spark plug wires coming directly off this ignition coil, running up here to their respective spark plugs. Okay, so again, no distributor. Our ignition coil right here directly feeds our spark plug wires. Down here I've got the sensor, and in this case, this is a crankshaft position sensor for this style setup. Now, you see I've got like this red outline of my engine right here. So this guy is driven directly off of the crankshaft. Most cars is going to be on the front. We have a crank position sensor right here that is within a set gap from our reluctor wheel right here that is mounted to the front of our crankshaft in this. And you see as I spin this, I've got different grooves. I've got one groove there. Look, I've got two grooves. And I've got one groove, one groove, one groove, one groove. And these are spaced appropriately for how this engine is set up to run. And you see this double groove right here. This means cylinder 1 is going to be ready to fire, or I've reached top dead center on cylinder 1. So it has a reference so that the computer knows exactly what cylinder we're on in, again, the 4 strokes. So it can fire, it can spark that. We have some electrical connectors going to our car's ECU, our computer. We have spark plug wires just like we did, and then we have spark plugs up here. So now let's watch this guy work, okay? So I can turn this on. My switch is a little loose. You see, as I turn this on, I hear the spark, but look, my crankshaft is spinning, and it's spinning my reluctor wheel. My crank position or crankshaft sensor is reading those grooves in this reluctor wheel, sending that signal to our ECU. Our ECU is then activating our coil, sending electrical signal or electricity to our spark plugs, and our spark plugs are firing. And as I increase the RPMs on this, the faster it goes, you see, eventually, our spark plugs look like they're firing full time. They're really not. There is really a dwell or a pause between each spark, even though it doesn't look like it. See, and that was at 3,000 RPMs. That's what they look like. So imagine 6,000 RPMs. Our idle down here, we're at about 500 RPMs, so that's what our spark plugs look like at 500 RPMs. Okay, and again, we can see them, each one sparking as our crankshaft turns down here. Now, why do they call this a waste spark? Basically, this is called a waste spark system because if you look at this, I have one coil module here, I have one coil module here. Now, yes, they are connected, they're mounted to the same plate, they're controlled by the same signal, the same ECU, etc. But I have 2 spark plug wires coming off of this coil module. I have 2 spark plug wires coming off of this coil module. What that means is every time this module fires, it actually fires both spark plugs. Every time this module down here fires, it fires both spark plugs. And you can see this one's actually numbered cylinder 1 and cylinder 4. So this coil is in control of cylinder 1 and cylinder 4. So if I follow the spark plug wires up here, this one goes to cylinder 1, cylinder 4 happens to be right there. So again, cylinder 1 and cylinder 4. This guy right here controls cylinder 2 and 3. And again, if I follow the wires up there, that's where they go. Now it's, again, wasted spark because, as I mentioned, each time this coil fires, both spark plugs spark. And you're probably thinking, well, how does the engine run if 2 spark plugs are sparking? Doesn't that cause some bad thing to happen, some misfire, some ignition issues, etc., etc.? No, because what happens is, if you remember firing order, such as our 4-cylinder engine is usually 1, 3, 4, 2. 1, 3, 4, 2, 1, 3, 4, 2. So, cylinder 1 fires, cylinder 3 fires, cylinder 4 fires, cylinder 2 fires. 1, 3, 4, 2, 1, 3, 4, 2. So you see these coil packs are switching back and forth as far as which one works. Now the way our 4 strokes work, cylinder 1 fires, next one will be cylinder 3. Cylinder 4, then cylinder 2. Our twin cylinder right here on our coil pack is not on a stroke that would cause any damage. So it's probably on the exhaust stroke when these fire. So that there's really nothing to burn. There's nothing to spark inside the cylinder to cause any kind of issue. Okay? So it's on a stroke to where there's no air and fuel in our cylinder, so it causes no problem. It causes no issue. Okay? So that is a waste spark system. They call it a waste spark because one spark does nothing. It's sent to a cylinder that is not making power at that stroke, and it does nothing. So in essence, it's wasted. Okay, so that's why they call it a waste spark system. If this was a V6, I would have a 3rd coil pack. V8, I'd have a 4th coil pack. But again, same setup of a wasted spark ignition system right here. So this is a direct ignition, okay? Again, the coils directly feed the spark plug wires, which directly feed the spark plugs. And remember, we've got a sensor, engine sensor, that is watching what our engine is doing, sending those signals to an ECU, and then the ECU is actually firing our coils. So this is a modern ignition system. Okay guys, so I wanted to show you something called coil near plug. Okay, that's this guy right here. And what this is an ignition coil off of a Chevy LS based engine. And we call it coil near plug because if you look at something, I have an ignition coil right here. I have one spark plug wire coming off of that ignition coil that comes down and then plugs into my spark plug. So it is a very short plug wire. Where they put this coil, it's mounted on a bracket onto the valve cover. And again, this is Chevy LS engines. The nice thing about this guy is there's one coil for every spark plug. So we have individualized coil for every cylinder. And that's what modern engines do. We've gone away from the distributors. We've gone away from even the GM HEI or the waste spark system. We now have what's called coil on plug or coil near plug. And again, the big advantage with that is we have one coil controlling just one spark plug. Okay? And what happens with that is it makes it easier for misfire diagnosis, because if we say we have a cylinder misfire, the code says cylinder 5, it's watching cylinder 5's ignition coil, and the computer can easily detect a misfire. Instead of just throwing a random misfire code or a multiple misfire code, we now have individual misfire diagnosis. We also have individual cylinder control, which means I can adjust ignition timing individually based on cylinder by the computer, what the computer is seeing. And then I can control this ignition coil individually for each cylinder for what the conditions are and what we need. This has a plug right here on the end. This is where our connector plugs in. That is from our wiring harness, that is from our ECU, our ICM, whatever controls our ignition coils in whatever vehicle. We have individualized cylinder control, okay? And again, this is a coil near plug on like a Chevy LS engine. Over here we have a coil on plug type engine, and this is what most of our cars are out in the lab. You see I've got 1, 2, 3, 4. These are our ignition coils. They're mounted to our valve cover. But if I pull one of these out, you see here's my ignition coil. I have a very short, sometimes rubber, this is plastic boot or lead. Then I've got a rubber boot on the end. And then down in that hole, that's the top of my spark plug. So this guy literally sits on top of our spark plug. And again, that's why they call it a coil on plug. Individualized cylinder control. Okay, we have our connector right here. And just like our coil near plug, we have individualized cylinder control, individualized ignition control. Again, helps with misfire diagnosis. It's also for emissions and power. We can control each cylinder's ignition individually. Okay, right here I've got 3 spark plugs, and these are all 3 out of the same engine. Okay, so here's a spark plug. What does a spark plug do? It makes a spark. Okay, they mount in the engine like this. I've got a threaded base that also acts as my ground. I've got a ceramic porcelain insulator, and then I've got the top electrode. This is what the spark plug attaches to, or my coil on plug will attach to this. It's got a metal core that goes all the way through it that comes out to the other end where I have this very fine little point. That is my electrode. It is, again, surrounded all the way through this spark plug by a ceramic or porcelain insulator. Our ground base right here is what screws into our cylinder head. You see I have a ground electrode right here that is attached to that. So what happens is our spark is sent through our spark plug from our coil or our spark plug wire. It travels through our spark plug to the electrode, and then it jumps from the electrode to the grounded base, and we get a spark. If I look at the color of this electrode, it can tell me how well the engine's running. You see, this one looks pretty clean. It looks pretty nice. Okay? These other 2, this one is really black, and this one is black and kind of goopy looking, if you can see it. Okay? Reading spark plugs is looking at spark plugs after they've been run in an engine, and you can do some diagnosis on the engine. You can see if the engine is burning oil, if it's running rich, if it's burning coolant, or something else is going on, running lean, running hot. But this goopy black mess on these 2 plugs usually means that this engine was burning a little bit of oil or a lot of oil. If we have a nice, clean, good-looking plug like this one, and again, it's going to be discolored because it's in a running engine, but this one is a whole lot cleaner than these 2. So that tells me that that cylinder was healthier than this cylinder or the other cylinder. All right, guys, so I wanted to show you some of our ignition components kind of up close here to where it'd be a little bit easier for you guys to identify this stuff. So obviously this guy right here, if you think back to our old style ignition system, this is our ignition coil. Just a big round, like can of Red Bull sized ignition coil right here, okay? I've got 2 electrical connectors on top of it, and then I've also got my center tower right here. My center tower is where my spark is going to come out of my coil and go to my distributor. My 2 electrical connectors, one is usually labeled positive and one is usually labeled negative, okay? Because it does matter how you have these wired in. And you see this side right here, I have a plus. This side right here, I have a minus. So I have positive and negative terminals on my ignition coil, okay? And you see it even says right here 12 volt. Now, older vehicles, and I'm talking like the 50s and older, they did have 6 volt systems. Even early Volkswagens, the Beetles and such, had 6 volt systems, which meant instead of 12 volts, like you see this coil is labeled for, they actually used 6 volts. Okay, so a little bit of difference that you're going to see is you cannot use a 12 volt coil on a 6 volt car. You cannot use a 6 volt coil on a 12 volt car. Why? 12 volt coil on a 6 volt, it won't make enough spark. It may barely run, it may not run at all. A 6 volt coil on a 12 volt car, you're going to burn that coil up pretty quickly, okay? So this is our old style ignition coil, okay? So we have what's called a primary side and a secondary side on our ignition systems. Our primary side are going to be these 2 connectors. This is our primary ignition coming into our ignition coil, or our voltage, okay? So we have primary side. The secondary side is going to be this tower, what goes out to our distributor and then to our spark plugs ultimately. Our primary side of our coil, if I were to cut this ignition coil open, you would see a coil of wire wrapped around the outside here. And now our primary side, we use a couple hundred coils of wire, a couple hundred wraps times around this, and it's reasonably thick. It's not super thick, but it's thicker than our secondary side windings. We use 100, 200, 300, depends on what we want the coil to do. But again, it's wire wrapped around inside of this. Our secondary side, this tower right here, it has a metal core with much thinner wire wrapped around many hundreds, if not thousands of times. Okay? And that's our secondary side. So our primary side is wrapped around our secondary ignition side. Our primary side, when we apply power to this coil, charges. It induces a magnetic field inside of our coil. Okay? When we break that magnetic field somehow, we disconnect it from power, meaning we usually ground out one of the sides of the coil. That magnetized voltage basically will have to go somewhere. It can't just sit there. When we lose a connection, that voltage has to go somewhere. Think static electricity. When you walk up to the doorknob and you touch the doorknob and you shock yourself or another person, okay? You have built up electricity. You have now ground it out to something and created a spark, okay? Well, our primary side charges up. We take away part of that primary side. Now that magnetism, that energy has to go somewhere. What does it do? It jumps to our secondary side. Okay? And then from our secondary side, it gets increased and sent out to our spark plugs, and we get a nice, good spark. Okay? So primary side is our voltage coming into our coil. Our secondary side is voltage coming out. We only have 12 volts coming into the coil. We can have 10,000, 20,000, 50,000, 100,000 volts coming out of the coil. So that's what happens. This is a transformer. This steps up voltage from 12 volts to tens of thousands of volts. Our primary side builds it. That voltage jumps to our secondary side, increases even more, and bam, we get a spark. So this is our old basic coil. Okay? And from this guy, we went to our HEI system. Okay, so here's our HEI distributor cap off of our system. Okay, so our coil is this top part right here. We have a plug right here on the bottom. This is the power in. This is also our connection to our ECU or our ignition control module, depending on the vehicle. Inside of the cap, again, we have our center button right here. The other side of this center button is going to be our coil. And then you see we have the points or the electrical contacts right here that each one is connected to where a spark plug wire would go. So this is our HEI cap. We can replace just the coil if we wanted to. It just simply unbolts. There's a couple bolts. Coil comes off, and we can replace the coil, or we can replace the cap, like if we're doing a tune-up. Okay? Not a huge issue either way. Our distributor. This is what our distributor looks like in our HEI system. Okay? I have the cap off. The rotor is off of this. But one end right here is geared. This is actually driven by our camshaft. So as our camshaft spins, this spins our entire distributor. Okay? Inside of here, you see I've still got a condenser right here. But right here, where I should have breaker points, if you think back to the older style that I showed you, this is our magnetic sensor. This is our Hall sensor. And if you can look down inside of here, and I know the lighting's kind of bad, but there's actually magnetic points or magnetic triangles right here. And let's see if we can see one. There's one right there. Those triangles, there's, depending on how many cylinders I have, this is a V8 distributor, so I should have 8 of these triangles. I've also got more little tiny triangles that spin right here when our distributor turns. But basically, these little triangles, whenever they pass each other, they send a magnetic signal that is picked up right here by our sensor, our Hall effect sensor, and that is then signaled to our ignition coil or our ignition control module, and we get then spark plugs fired when they are supposed to based on our distributor turning. This guy right here is called a vacuum advance or a vacuum retard. Basically what that means is based on engine load, I can advance or slow down ignition timing. Okay, this can slide right here, which then can slide this mechanism, and it's all stuck. Might be why this guy got replaced, but it can actually advance or retard ignition timing in our distributor based on what we need. Okay, so there's our HEI distributor. Here's our waste spark distributor. I've got 2 different versions of waste spark right here, our coil. I'm sorry I said distributor. This is our ignition coil. Remember, waste spark, we don't have a distributor. It's all computer controlled. We have sensors that read our crank and or cam position, and we have a computer that then controls when this coil sparks. You see right here I've got numbers. This is what individual cylinders this waste spark system controls. So you see I've got 6, 3, 5, 2, 4, 1. So hey, this is a V6. This little coil right here controls cylinder 6 and 3. This one controls 5 and 2. This one controls 4 and 1. Okay? And remember, it's called waste spark because each time these coils fire, it fires both spark plugs. Same thing with this guy right here. This has just got the plug wires attached. Cylinder 1 and 4, cylinder 2 and 3, and then we've got our spark plug wires still attached to it. Okay, so both of these are waste spark. And then if you remember our little LS distributor, right, or I keep saying distributor, I'm sorry. Our little LS ignition coil right here, the LS engine and most modern cars, we have 1 coil per cylinder, which once we connect our spark plug wire, our spark plug wire goes down and only feeds 1 spark plug. So we have 1 coil controlling 1 cylinder. Again, great for emissions, great for misfire diagnosis. We can play with timing even more on our engine. So hey, we can eke out more power with an individual coil on each spark plugs. And this is again called coil near plug, or some people might call it coil on plug. Technically it's not, because the coil is not mounted to the spark plug. We still have a little short ignition wire or spark plug wire. The actual coil on plug, that's this guy. Okay, our ignition coil is right here. We have this rubber boot right here, or sometimes it's plastic. This one happens to be plastic. And then our spark plug is down here, slipped into this end of the boot. So this is a true coil on plug. This is what you're going to see the most on modern vehicles, and pretty much everything new has coil on plug. We don't even fool with coil near plug anymore. Chevy still does. Maybe somebody else out there still does, but for us, most cars are going to be this coil on plug now. Okay? So how do we test any of this? Well, we can do a couple simple checks. Our old coil right here, how do we see if it's good or bad? So look at our old system right here. Well, we have our primary side right here. Again, we have wire wrapped around this guy. One end comes in, is wrapped around, it comes out the other side. How do you think we would check this ignition coil to see if it was good or bad? It's simple, resistance. We would simply use our good old DVOM right here, digital volt ohm meter. We turn him to resistance right here. You see we have OFL, out of range, right here. And I'll try to get this to where, there we go, we can see our reading. So I would simply take my leads and connect my positive to one side of my ignition coil. I would connect my negative to the other side of my ignition coil, and bam, we have a reading in ohms. It looks like 1.96871. It's fluctuating a little bit, but about 2 ohms of resistance. Now, there should be a spec for this somewhere. You'll have to pull up the repair manual and look for that spec, but there should be a spec for resistance across our coil, okay? If it's in spec, the coil in theory should be good. Now, one thing that can happen with this, heat. We can actually have a broken wire either on our primary side or our secondary side that when the coil's nice and cold, it can be touching. But what does heat cause things to do? Heat causes things to expand. So we can actually have a coil that gets hot and the wires expand, opening up and causing that break to open, and we can get increased resistance because it might be just close enough that we have electricity jumping that gap, or we get an open because it's opened far enough that we get an open on this. So you might have a car that runs great cold and then starts to misfire when it warms up and then dies or just absolutely does not start when it's hot. You could have a break inside of this, either on the primary or the secondary side. How do we check our secondary side? Same thing, we're going to check resistance, and we're just going to look for continuity between our primary and secondary side. Okay, if our resistance on our primary side is good, and if we check primary to secondary resistance, you see I have 10.4 K ohm or 1,000 ohm. Again, depending on the spec, that may be good or bad. Okay, but always refer back to the spec. But if I had like 2 ohms of resistance, like if I had the same amount of resistance here as I did here, then I would have something shorted inside of my ignition coil, and I would have a bad ignition coil. Okay, how do you check the modern, newer coils? Kind of the same thing. We're going to look at our plug right here, and you're going to pull up the spec. And again, depends on the manufacturer which terminals we're going to use, but this guy really only has 3 terminals. So I'm just going to kind of take a guess here and hope that I get some sort of reading without pulling up the old repair manual and seeing what kind of readings I should have. So I'm going to try. I got 1 lead on the first terminal. My second terminal right here. Look, I've got 2.8 K ohms. First and third, I've got 492 K ohm. Okay, so let's go second. Second to first, 2.6 K ohm. Second to third, 2.8 K ohm. Okay, so again, I'm looking at what the specs are for this, okay? It just depends on the manufacturer. I'm looking for specs, and you see I've got milliohms right here, or mega ohms. So lots of resistance there. But again, I'm looking for specs. Spark plug wires, you're going to check them the same way, okay? So spark plug wire, and let me just use just a, generic spark plug wire I've grabbed here. Same thing. How do I know if my spark plug wire is good? I'm going to check resistance, okay? And again, you should have a spec of how much resistance you want across this spark plug wire. And you see right here, I have got 6.9 K ohms, or 6,900 ohms. Now, depending on the spark plug wire, some say 10 K ohms per foot. This is about a foot long. Who knows what the spec is on this? Depends on the vehicle. But this might be within spec. I might have really high resistance in my spark plug wire and be in spec. Why high resistance? Well, that means our ignition coil has to output more energy to go through this plug wire, which in theory means I get a hotter spark. Okay? So that's why spark plug wires have resistance to build that energy in our coil so that we get a nice hot spark. All right, so let's go over the parts of our spark plug here before we check it again. This is our spark plug. So again, we have a porcelain ceramic insulator right here that is the part that we see sticking out of our engine. Right down here we have our threaded base. This is what threads into our cylinder head. We have a hex head right here where we can put a wrench or a ratchet or socket, whatever we're using to remove this. Down here we have our ground right here that is connected to the base of our spark plug. This allows our spark to ground through our cylinder head. At this end we have the electrode that the spark plug wire slips over. On the other end we have our actual electrode, the very, very fine tip right here. This is what sparks. Our energy jumps from our electrode up to this ground strap right here. So that's what makes our spark. Our electrode is surrounded in porcelain ceramic down here as well. This ceramic part is the entire length of the spark plug. Okay? So that's very important. We don't drop a spark plug. We don't bang it against something. If we do drop it, we need to look it over really, really well, or check resistance, or we throw it away and use another one. Okay? This gap right here, the gap is what is the space between the tip of the electrode and the ground. Gap is very important as well. And we can check that with a spark plug gap tool, feeler gauges, etc. But if the gap is too large, it becomes very hard for the ignition coil to make enough energy for that spark to jump that gap. If it's too small, then we have other issues with not enough energy because it's a very narrow gap. We might have incomplete combustion. We might have a misfire. There's several other things that happen with a too small of a gap. So we want the gap to be whatever the manufacturer specifies. So how do we know if our spark plug is good internally? We do a resistance check. So again, we have our meter set on ohms. I just connect one end of my meter to the end of the spark plug, and then I can check my resistance right here at the base. And you see right here I have 0. I have out of limits. That's good. That's what I want. Okay? Down here at my electrode, if I touch it, I have 4.7K ohms, or 4,700 ohms right here. Again, look at whatever the manufacturer's spec is to find out if that is good or bad. Again, we want a high resistance in our spark plug. That makes our ignition coil charge and throw out more energy because we want a good hot spark. And again, as our engine runs, this gap also wears. It opens up more. So just because a spark plug might look good and test good, again, we have to check this gap. We have to measure for continuity right here as well. And you see, look, right here, I get a little bit of continuity, 3.2 M ohms or mega ohms. But again, check your resistance of your spark plug. Do a visual inspection. We showed the reading of a spark plug. Again, we're looking at what color the electrode and everything associated with it is. Is it oil soaked? Is it fuel soaked? Is it black? Is it look like it has little metal shavings or glitter in it? But we're looking at our spark plug. Okay. So again, I hope this helped everybody as far as identifying all these parts, looking at how our ignition system works, looking how everything runs and operates. I hope this helped all of you with just a basic ignition system.